All right, so today we're picking up where we left off yesterday. We're going to call this objective 5.1b. So today we're working on exponential functions and their graphs, day 2. And today, your objectives, you can define and graph a base E exponential function. So we'll talk just briefly about what E represents, how to find it on your calculator. I'm not going to go into great detail about it today, but when we learn about the natural log, when we start doing logarithms, I'll talk about it a little bit more. Well, and I'll also talk about it tomorrow a bit more when we're doing continuous compound interest. So we'll talk about it then. Also, that should not be number 5, but number 2. This originally was a set of notes that had 5 objectives. It's like 3 pages long. So objective 2, you can define and graph vertical and horizontal shifts of the form y equals, or f of x equals base to the x power. So we're going to go back to our shifts, our translations up and down. It should be a really seamless transition from when we were graphing shifts of our rational functions and our polynomial functions. Okay, so here we go, starting with base E. All right, base E is comes from this guy Euler, and it's called Euler's constant. He was a really famous mathematician who actually, interestingly enough, became famous. A lot of the stuff that he published and he discovered was done after he became blind, which was really interesting to me. Euler's constant. Anyway, E right now, for today's purposes, I'm just going to tell you what it equals. E is equal to this value, 2.7182818 ... forever and ever. You see that pattern developing there. And what we're going to do is just approximate it to 2.72. So we're going to use it to the hundredths place. Okay. And it's basically, you know how yesterday when we were talking about base 2 and how things double and double, and your origin is you were an egg, and then that egg became 2 cells, and then those 2 cells became 4, and those 4 became 8. Remember that? Talked about that yesterday. Well, Euler's constant is more, how does something grow continuously? It is always growing. It's not one thing that becomes 2. It's one thing that morphs into 2, and it's constantly just expanding. Like you'll see it out in nature. If you watch how a cactus grows and it kind of spirals out and then it just gets bigger and bigger, and it's a really beautiful pattern. Well, E is part of that growth pattern. Okay, so that's what we're going to be using today. We're going to graph it on a graph. Okay, all right, you ready? Yes? You guys are being quiet because you don't want to be in my video. Let's graph it. Okay, so this is a base E, and actually on your calculator, you have E to the X. It's on the button that says ln, okay, which is 2 down from your second button. It's second, and then it says your log button, and then it says your ln button. The second function of your ln button right here says e to the x power. You see it? There it is. So it's the inverse of the natural log, which, and when we do logs, I'll explain it in a lot better detail. Okay? So we're going to be using that when we plug it into the calculator. So we will be plugging into our equation, our calculator, e to the -1, and we are going to get to 2 decimal places today. Is it 0.39 or 0.38? I don't remember. 37? 0.37. Okay. So, of course, we couldn't really graph that perfectly, but we'll just imagine that we're doing a good job and putting it exactly where it belongs at -1 up 0.4-ish. When we plug in e to the 0, honestly, we don't need to plug that into a calculator. Everything to the 0 power is 1. All of these functions have the turning point on the y-intercept of 0, 1. E to the first power. We also shouldn't have to plug that into the calculator because I told you it's 2.72. Of course, you could plug it in if you forget. So we're going 1 up 2.72. And then we'll need to plug in e squared. So you guys do that. It's 7.3 something. I can't remember. 9? Is it the 8 rounds up to the 9? Okay. 389. Okay, so 7.39. So we go right 2 and up 7.39. So 4, 5, 6, 7.39. And there is an example of how something grows continuously. It's not doubling, it's not tripling, it's just always growing over time. With a horizontal asymptote, I think I'll change colors. We are approaching, remember that we can, it doesn't matter what exponent we plug in that's negative, we can never reach 0 when we graph. Okay? And if you look at this pattern of these points, it's hard to see, but what's happening as I go left is I'm dividing by 2.72, dividing by 2.72, dividing by 2.72, and I'm just going to keep dividing by 2.72 as I approach negative infinity, and that number will get smaller and smaller and smaller, but it'll never be 0, and it will never be negative. So you have a domain that is unrestricted, a range that is approaching or non-inclusive 0 to infinity. Okay, and then let's talk about its interval of this is an increasing function, and it's always increasing, right? On the left, it's until we get to the turning point 0, 1, it's increasing really slowly. And then once we hit the turning point 0, 1, it starts to rapidly increase once we get into positive values. So it is increasing. It's an increasing interval on the interval negative infinity to infinity. And let's quickly talk about its end behaviors. So on the extreme left, as x approaches negative infinity, what's my y approaching? Or my output's approaching 0. You got it. And as I go to the extreme right, as x approaches positive infinity, y is approaching infinity really quickly. And that graph goes to the moon and beyond. Okay, so there's your Basee function. All right, moving on to our translations, our vertical and horizontal translations. So here it looks a little different than, the formula looks a little bit different than what we did when we were doing our polynomial function translations and absolute values, but the same idea still exists. So you have these 4 examples. There's 4 examples because you can either move up, move down, move left, move right. That's 4 ways that you can slide a graph. Right? Well, of course, you could move it diagonally, but that's a move left and up or right and down or whatever. Okay, so we're going to look at these base functions, y equals f of x plus k minus k, x plus k, x minus k, and we're going to talk about how it shifts the graph. So we'll start with this one, y equals f of x plus k is identical to the graph y equals f of x, except that it's translated k units up, because the k, which in our case, we were talking about it as a d term, if you remember, right, is not included with the x, so it's a vertical action, and we do exactly what it says, plus k, so that's up. Okay, let's look at the second one, y equals f of x minus k, vertical action again, not included with the x, that's going to move the graph down k units. You got it. Then we move to number 3, y equals f of x plus k, closed quantity. That's grouped with the x, which means it's a horizontal action, and you always have to zero out your horizontal action. So this would be a move left, because you need a negative k to make that positive k 0. So you're trying to shift your 0 left or right, whenever your x is 0. Okay, then we'll look at the last one here, y equals f of x minus k. So what kind of k would make a minus k a 0? A positive k. So you'd have to move the graph to the right. Okay, so that's just a review of something we've already practiced and we already know. So let's use that to translate some base functions here. So here I have in my example, I'm going to move my screen up a little bit here. Not that. Well, let me move it. There we go. All right, so we're going to color code these. So your colored pencils out. I think I'll graph my base function in gray. We're going to graph all of these functions on the same graph, but we're going to graph them in color. So I'm going to graph A in gray, B I'll graph in red. You, of course, can pick whichever colors you have available. C I'll graph in purple, and D I'll graph in blue. Okay, so what we're going to do is on the same set of on the same axis, we're going to graph the given functions using translations of the original function, the base function that doesn't have any shifts in it. And then we'll describe the transformation. Sorry, it's a capital T. It's not supposed to be. I don't think on your paper it's capital T. Okay? And explain any shift of the horizontal asymptote. So we're going to do all of that. So we're going to start with A. So A passes through what points? It passes through -1 and reciprocal. What's 2 to the -1? Come on. 1/2. And it passes through 2 to the 0, 1. And it passes through 1 and 2 to the first power is 2. So we know it's going to pass through those 3 points. Okay? -1, reciprocal of B, 0, 1, and 1 base. We know it's going to pass through those points, so let's graph those. So -1 up 1/2, 0 up 1, and 1 up 2. Let's also do 2 up 4, just so that we can get some good points, right? 2 squared is 4. Let's also graph 2 cubed. Or 2 cubed would be 8. So we'll go 3 up 8, just so that we can get a nice dramatic curve there. Get your asymptote in there. You're approaching 0 to -infinity. Growing very rapidly as you pass x equals 0. So there's your base function. Doesn't have any shifts in it. Okay? Passing through -1, reciprocal of the base, 0, 1, and 1 base. Okay? And let's move to number B. In math, you know B is a number, right? Because it's always representing some number. All right. So let's take a look at this. It's the f of x equals 2 to the x. And what am I doing to this graph? Look at this +2. Horizontal or vertical action? Vertical action. And we're going to move this graph up 2. So we're going to take our blue function, f of x equals 2 to the x power, and shift all the points up 2. So this point's up 2, up 2, up 2, up 2, up 2. And that also shifts the horizontal asymptote up 2. So everything gets pushed up. So also draw in your new horizontal asymptote. Come on. Okay, there we go. And so we described the transformation. We said we took the base function and pushed it up 2. And now it says explain any shift of the horizontal asymptote. The horizontal asymptote is now, instead of y equals 0, it's y equals 2. Because we shifted it up 2 from y equals 0. Let's talk real quickly about our domain and range. because this is what I'll require you to do on your homework today. Your domain is unrestricted. And how about your range? 2 non-inclusive to infinity, because everything shifted up 2, so your asymptote is now 2 higher. Yes, you know, on the original, your range was 0 to infinity. Okay. All right. Switching to points or to graph C, f of x equals 2 to the x minus 3 power. Okay, so this time the k term is grouped with the x. So is it a horizontal or a vertical action? It's grouped with the x. It's a horizontal action. So we're trying to zero out what's happening here. We're trying to make it say 2 to the 0 power. So what would our x have to be? Positive 3. So that means it's going to shift the graph 2 to the x power right 3. And I need to put an R for right. Right 3. So it's going to push all the points to the right 3. So instead of 0, 1, we're now going to graph 0, 3. And then all the points will shift right 3. Question?
How do like add the n plus 2 at the end? Would you shift your second graph to the
You would push it up 2.
like I mean
Oh, yes. So you would go right 3 and up 2. Yeah. Am I going right 3? Oops, I made that one only right 2. Let me fix that one. Right 3 and right 3. And again, you're moving the base function. I'm moving my blue function. And then regraph. Okay. Did we shift our horizontal asymptote? Because we have to explain any shift. There wasn't any shift. So what's my horizontal asymptote? Y equals 0. With a domain, unrestricted from negative infinity to infinity, and a range, non-inclusive 0 to infinity. Okay, and then we're going to go to D. And here we have it. We're taking the f of x equals 2 to the x power, and let's look at what's happening here. We have 2 shifts. We have a horizontal shift and a vertical shift. So first let's talk about the horizontal shift, because you're always affecting your x before you affect your y. X comes before y in the alphabet, yes? Okay, so what x would zero out this positive 2? So we're going to move left 2, and then what y? What will we do with the graph once we move it left 2? This is a vertical action, right? So we're going to move it down 4. Left 2, down 4. Oh, I think I was going to do the original graph in gray. Oops. Shoot. I'm going to go back and fix my gray function here. I'm going to just make it gray. There we go. Okay, so we're going to shift all these points on my gray function to my blue function here. So we're going to take these points and go left 2 and down 4. 1, 2, 3, 4. Left 2, down 4. Left 2, down 4. Down 4. So you should be crossing at the origin, and then left 2, down 4. And also move your asymptote down 4. Okay? So we've described the transformation. We moved it left 2, we moved it down 4, and our horizontal asymptote also shifted down 4 to y equals -4. That's right. Okay? Any questions about that? Okay. Then on the back, I would like you to try this one without me. So I'm going to pause the video while you try. So you can press pause. Okay, so there's the graphs. Check your work against mine, and you're going to write a summary of what you learned today, and you will be also on your homework that you picked up today. You will be doing problems what did I say? 31 through 40, and then 43 through 58. And you can do the assignment on the actual assignment. You have to do it on your separate paper. On the graphs of the transformations, I expect everything that we did in notes to be done on the assignment, regardless of what the instructions say. Graph the base function, graph the translation, describe the translation, and shift of the asymptote, domain, or range. Thanks.